I'm Anil Kumar. Welcome to our series on vectors. Here is a very important lesson with brilliant student Akshat. We'll discuss two questions based on relative velocity. We'll consider resultant velocity in both the cases using two different methods, one trigonometric and another one resolution of vectors. In case you want to learn from me, you can always write an email on the address given. Let us now enjoy the journey of learning. Hi Akshat, how are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So today, what do you want to learn?
Sir, I was hoping we can pick up from where we left with vectors and continue expanding upon it.
Okay, sure. So last time we saw what vectors are. They are both magnitude and direction. The direction can be given as a bearing
Right.
angle or also with the coordinate planes, right?
Right.
North of east or something like this.
Yeah.
And then we could have two vectors and we can just give you relative direction between the two vectors and work upon those things. You also saw how do we add the vectors. Basically, we apply the cosine law to add the vectors.
Right.
And you have to place the vectors. If you have to add vector u and v, then in that case, at the end of u, which is the u head and tail, right? So at the head of the u, put the tail of v, and then join them to add them. So from here, we'll continue forward. I'll take now real life situations, involve relative velocity, and then that should help you a lot. Since you have good base in physics, it should be a very interesting question for you. So let me share with you the word problem which I'm talking about, and we'll go from there.
Okay.
So can you see my screen, please?
Yes, sir. I can see.
Okay, so we'll represent the vectors. We'll resolve vectors in components. We'll add vectors. We'll find resultant magnitude. We'll also find resultant direction of vectors. That is the exercise which we are going to do. Here is an example for you. Can you please read the example?
Yes, sir. An airplane is flying on a bearing of 345 degrees at 330 miles per hour. The wind is blowing with the bearing of 300 degrees at 40 miles per hour. Find the actual speed and direction of the airplane. Bearing angle is measured from north in the clockwise direction.
Correct. So, as you know, bearing angles are measured from north. So, if this is the north for us, right? Let us say the east for us. We can say north and east. So when I say airplane is flying on a bearing of 345 degrees, 345 degrees, it means what? It means that from the north, we go like this all the way, and it is like 345. Do you see that?
Yeah.
That is what it means. So the airplane is flying at this, in this direction.
Right.
So if it is, that is 345, what is the acute angle here? Can you tell me? 360?
Yes, sir. It would be,
How much is that?
15, sir.
Correct. So that is the airplane. And as we said, in vectors, two things are important. One is magnitude, the other one is the direction. So we got the direction. Magnitude is 330, which is miles per hour, right? So the length of this is representing 330 miles. Is that clear to you?
Yes, sir.
Now, wind is blowing with a bearing of 300 degrees. 300 degrees, if you take away from 60, then really it is how much less? 60 less, right?
Yeah.
So you can say kind of like this, right? Let's make it.
Right.
And of course, it is 340 miles per hour, so it has to be much smaller. So let me just reduce the length.
Okay.
So we know that the first one, which is the plane, has got 15 from the vertical, and here 60 from the vertical, right?
Right.
So the angle between them you can work out. Do you see that 60 minus 15 we can get?
Yeah, you can.
Correct. So how much it is?
It'd be 45.
45 degrees. So 45 degrees is the angle between them. You get the idea. So we have the status. And from this status, we need to figure out what is the actual direction of the plane and what is the actual magnitude You see, in some way, the wind is helping the plane, right?
Yeah,
The velocity is
right.
going to be higher,
Yeah,
correct? So we say that is a resultant. That resultant we can find in many different ways. One, we call this as a parallelogram of forces, and we can also use a triangle. Both give you the same result. So let me just show you both the methods on a blank page, slightly bigger. And the other one is the wind velocity. We have to add these two, correct? So I'll
correct.
show you two different ways of doing it.
Yeah,
Resultant is basically connecting this point with the end point.
right.
So that is the resultant for us.
Yeah,
At this particular diagram, we know that the wind velocity is 40 and this is 330. So we know two sides, correct?
correct.
We need to find the angle in between and we can use the cosine law.
Yeah,
What is the angle in between? Can you help me figure this out? Let's draw a vertical line here.
yes, sir.
If I draw a vertical line, this is 15, that should be 15, right?
Right.
And from the vertical line, what is the angle from vertical line to this? That is the angle, right?
Right.
Which is, this was 60 for us, this is 30 for us, right? So 120,
Yeah,
90 plus is 120.
yeah.
And therefore, the total angle is
A 135.
135. And therefore, we can find the resultant, right?
Yeah,
Use cosine law because we know two sides and the resultant.
right.
Let me write resultant square, we'll do square root later. So we have
Okay.
40 square plus 330 square minus 2 times 40 times 330 times cos of 135 degrees. So minus and minus will become plus, right? Cos
Yeah.
135 will be positive 1 over square root 2. So what do you get? And then square root it.
So with the square rooting and everything, you get 360.
360. So resultant magnitude we found as 360. You get the idea?
Yeah,
And you can also find the direction
right.
using sine law now, right?
Yeah. And so you can report the angle from anywhere, right?
Yeah. So theta, yeah. So let's find this angle theta.
Okay.
So what is this angle theta now? So we can use sine theta.
Yeah.
Over 40, which is the
Yeah.
opposite side, is equal to given to us is 120 sine of 120 135
Yeah. Over 360.
over the side 360, right? 360
Yeah.
not degrees but miles, right?
Right.
Right, miles per hour. So you can find sine theta from here. So what do you get?
So you get approximately 4.51 degrees.
So you get 4.5 degrees, right? So
Yeah.
from the bearing angle point of view, you can add 4.5 to 15 and take away
To 15. Right.
So bearing angle will be how much?
So say it would be, you take away from 60, right, sir?
Yeah, 15 and 4.5.
Yeah. 340.5.
So this is how you could do it using the concept of sine law and cosine law. You get the idea.
Yeah. Yes, sir.
Now, let us use vectors to find the same answer or similar situation. Is that clear?
Okay.
Let's do vectors now. So how do we do it? We can resolve each force, each component or each vector into
Yeah.
its horizontal and vertical components.
Oh, okay. So basically you can break down the vector, right, sir?
You can break down the vectors. Yes.
Okay.
So when we are talking about this particular question, let's make a new diagram.
Yeah.
So For example, this is our, let's say, velocity 330, right?
Yeah.
Miles per hour. And let's say this is angle of 15 degrees, right?
Right.
Total was how much? 300 and
So I
total.
think it was,
Okay, anyway, we can use 15 itself.
yeah.
So we can resolve it into these two components. Do you see that?
Right. Yeah.
So the vertical component, as we had said, it writes as J, unit vector.
Yeah.
And this is I, right?
Yeah.
So in this case, if this is 15, then what is the horizontal component? It will be 330 sine of 15, right?
Sine of 15.
So we can say velocity of plane can be equal to 330 sine of 15 degrees. But since it is going in this direction, we can say minus, right?
Right.
I. Is it okay?
And so this would be VPX, right?
Oh, yeah. So I'm writing both together.
Okay. Yeah.
So that is the x component. And the y component will be positive 330 cos of 15 degrees j. Do you see that?
Yeah.
So unit vectors, we put a cap here. So that means they are, as such, I and j are unit vectors.
Yeah.
Good to put this. Now let's talk about the wind. So it was 40, right? Magnitude.
Yeah.
And the direction we worked out, this was 30 degrees, correct?
Yeah. 30 degrees.
So velocity wind can be written as, if this is wind, then the horizontal component will be cos theta, right?
Right.
Minus 40 cos of 30 degrees, right?
Yeah.
I. And the j component will be upwards plus 40 sine 30 degrees.
30. Yeah.
J. Is that clear to you?
Yes, sir.
Now, when we do addition of vectors, you can combine in the same directions I components and j components. Is that okay? So that is the resultant. So we want to find the resultant. Resultant is the sum of these two vectors. Is that clear to you?
Yes, sir.
So the sum is, in the I direction, we have what? We have minus 330
Yeah.
sine of 15 degrees plus minus 40. So it becomes minus, let me write minus 40 cos of 30 degrees, correct?
Yeah.
So that is the I component. And the j component is 330
Yeah.
cos 15 plus 40 sine 30.
Yeah.
Right? So you can use calculator, find these values. You know those components. Can you use calculator?
Yes, sir.
Basically, we have a negative sign here, but 330 sine 15 plus 40 cos 30. What do you get?
So I got negative 120.1.
Negative 120
0.1.
I, right? And about
Yeah.
j, what do you get?
And for J, sir, I get 338.8.
338.8. Good. You're fast calculating. Very good. So we have the resultant. Do you see that so easily?
Yeah.
Without getting into those complications of finding. So individually, each vector can be resolved along x and y direction. Is that clear to you?
Right. Yeah.
And what is the magnitude of this? We'll have
So we would,
a square plus b square square root.
right.
So just do 120.1 square plus what do you get?
Sir, I get the basic same thing we got before, 360.
Do you see the same? Not this miles per hour.
Yeah.
Do you see both? Obviously, they'll give you the same answer, right?
Yeah, right. Yeah.
So basically, what we are saying here is that the resultant is something like this.
Right. Yeah.
Now, we have to get this direction, theta.
Yeah.
So theta, as you can see, is y component over x component.
So just tan theta, right?
Yeah. So tan theta is equal to, the y component is 338.8 divided by 120.1, correct?
Yeah.
Do tan inverse and find theta.
Yes, sir. You get 70.5.
70.5 degrees. And the angle which will be reported will be this angle, right?
This angle,
You
right?
add 270 to this, right?
Yeah.
So the bearing angle will be 270 plus 70.5, right?
Right.
In this case. Is that clear to you? Do you
Yes,
see
sir.
how we have solved this question using two different methods, one using the
Yeah.
vectors, the other using the trigonometry, which you learned earlier.
Yes,
And
sir.
you can very clearly see the vectors method has a clear advantage. Very simple, right?
Yeah, it's very simple.
It's very simple and you can always use, but both are equivalent.
Yeah.
You could use any one of them.
Yeah.
If there are many forces, then the trigonometric method is very difficult because you cannot
Yeah.
keep on putting
Right.
one tail on the head and making it
Right.
smaller. It becomes very tricky beyond 3. It is very tricky.
Yeah.
You have to solve many triangles to get the answer. Here,
Right.
if we have more than 2 vectors involved, this is very easy
Yeah.
because you can all x components. We are only working with 2 components, x and y.
Yeah.
You get the idea.
Yeah.
That is how you have to solve these questions. Did you understand it?
Yes, sir. I got it.
Now here is a typed out, output which I'm going to share with you. We did some calculations and approximations, of course, correct?
Yeah.
This we said 370 rounded, right? 368.8 is the exact calculation. So when
Right.
you're working in trigonometry and you work on angles, do not round them. Use 4
Okay.
digits,
Yeah.
4 decimal.
Okay.
So use 4 decimal places to use your calculations. Then you're going to get the answers which I got.
Right.
And if you round them, you will get the round answer, which was
Yeah.
370, not 368.8. You get the idea.
Yes, sir.
Many times in these questions, they will say, write your answer to 1 decimal place. So you have to do fairly accurate.
Right. Sir, sometimes they may also like specify the significant digits too, right?
Yeah, significant digits. So
Yeah.
remember that part during our quick calculations, which you did amazingly well. I couldn't have done so fast.
Yeah.
And you got nearly the same answers, right? 340
Right.
and 370, correct? Same answers,
Right.
round to whole numbers.
Yeah.
I mean, so you see how we did exactly same velocity of plane. It has been resolved into 2 components, x and y direction. X direction
Yeah.
I, y direction j. If it is going towards negative, we do minus I. Right?
Minus. Yeah.
Similarly, the wind velocity has been resolved into 2 components. So I just solved and wrote the vectors here, right?
Right.
And then adding these vectors, right? I values and j values,
And
correct?
J values.
So we
Yeah.
got this sum. And of course, the magnitude calculate to 4 decimal places, then round it to the required place, especially
Yeah.
for the angles, correct? And then tan
Correct.
alpha. Once you know the angle alpha, you can add 270 to find the bearing angle. Is this part
Right.
clear to you?
Yes, sir. Clear.
Very important question from test point of view.
Yeah.
Definite question from test point of view. Is that clear to you?
Yeah.
So when you do vectors application, this is one of the first application, difficult question which you are dealing with. Okay.
Yeah.
Let me also deal with another type of question. So we are talking about vectors in air. Now let's take an example of a boat, and which is
Okay.
similar situation. Okay, right there. Can you please read the question?
Yes, sir. A Coast Guard Station O monitors the movement of small boats. At 10 o'clock, the boat is at the point 4I minus 2j kilometers relative to O. At 12:45, the boat is at the point minus 3I minus 5j kilometers relative to O. The motion of the boat is modeled as that of a particle moving in a straight line at constant speed. Calculate the bearing on which the boat is moving, giving your answers in degrees to 1 decimal place, and calculate the speed of the boat, giving your answer in kilometers per hour to the power of negative. So
Correct.
kilometers per hour.
Now, I'm only sharing with you 2 examples today, but you know the beauty of this?
Yeah.
This comes under the heading of algebra.
Right.
Since in this particular case, we have the coordinate points, you work with the distance formula, x1 minus x2 whole square plus y1 minus
Right.
whole square, things like that. You get the idea. And
Yeah.
the earlier question which we dealt with, it comes under the topic of vector geometry,
Okay. Yeah.
where you have to make the diagrams and work out your trigonometry kind of thing. So these are 2 different
Right.
chapters altogether in your book.
Yeah.
And these are critical examples for each unit. So for
Yeah.
geometry, that is the kind of question we are looking into application. I mean, other geometry
Yeah.
questions are very simple. We'll look into that later. But straight
Okay.
to, the good
Yeah.
question. And similarly, the board question, I have given you the coordinate points. You get the idea now?
Yeah,
So
exactly.
try to figure out these coordinate points. So I'm just making a rough diagram here. So when you say at 10, the boat is at a point 4i minus 2j, it means what? 4, 1, 2, 3, 4, and minus 2j means 1, 2. Do you see that? That is the location at 10.
At 10. Yeah.
So we can say that let this be the origin O, that this is my starting point A, which I'm saying I could also write this as 4 minus 2, column
Yeah.
4. So there are three different nomenclatures which we use. We can use a row, we can use a column, or
A
we could use
column.
the vector 4i minus 2j. Is that okay?
Yes, sir.
So this is the position at 10 a.m. I mean,
Right.
okay. And kilometers related to O at 12:45. That means after 2:45, 2 hours, 45
Yeah.
minutes, minus 3, minus 5. So you go to this place 1, 2, 3, and then 1, 2, 3, 4, 5.
Yeah.
Moves from here to there. Okay. Let's say that's the point, right? This is B.
Yeah.
Now see, so you make a diagram. So vector is very important to sketch a diagram. In every
Yeah.
question, you should be sketching a diagram so that clearly you understand what are the angles, what is the length, and everything, right?
Right.
Great. Calculate bearing on which the boat is moving, giving your answer in degrees to 1 decimal place. Calculate speed of the boat, giving your answer in kilometers per hour. Clear?
Right. Yeah.
So bearing means from the north, what is this angle? So look at this point, it is moving in this direction, right?
Yeah.
So the bearing angle means you want to find this angle. Is it okay?
This angle. Yeah.
Right? How will you find this angle? Tell me.
Sir, you can use the magnitudes that were given
Tan
with the
theta,
two
right?
vectors, right? Right. Yeah.
You see this angle theta? Now let
Yeah.
me just tell you what is tan theta. Tan theta basically is slope
Yeah. Y
y2
over X.
minus y1 over x2 minus x1. Just do it. So we have, you can say this is minus 2 and this
Yes.
is minus 5 becomes plus 5, right?
Yeah.
Uh, I did not write this point. Let me write this point also. It becomes much easier, right?
Right.
Okay, great. So we have minus 2, minus 5, and 4 minus 3, right? So we have got,
Yeah. 3 over 7.
so theta is, calculate.
Yeah. Tan inverse 3 over 7.
We have to write,
Approximately 23, sir.
yeah. Can you give me one decimal, please?
Yes, sir. 23.2.
Got it. So this becomes that angle theta which we are looking into. Is it okay? Now,
Yeah.
if this is the angle theta, in that case, what is the bearing angle?
So it would be 180 plus 23.2, right?
So bearing angle is, you have to see from here, because this is the movement, right?
Right.
So from here, north, that is the angle we're looking at. Is that clear to you? So
Oh,
if this
okay.
is theta, then what is this angle? 90 minus theta, right?
Right. Yeah, yeah, yeah. Okay. Yeah, I got confused. I was looking at the other
Yeah. So
axis.
you have to be careful. The thing is, you have to
Yeah.
be careful in these cases, which angle and then what. So 90 minus theta, you have to add to 180. You get the idea? Right? So it
Yes,
is
sir.
basically 180 plus 90 minus 23.2 degrees. Is that clear to you?
Yes, sir.
So, or you could say from 270, I have to take away that value. You could 270, right?
Yes, sir.
Because if vectors can be translated anywhere, right? So this line will be kind of like this. You see that?
Yeah.
So with the horizontal, if this is theta, this is also theta, correct?
Yes, sir.
So this is 270 minus theta. You get the idea?
Yeah.
So it
270
is
minus
better
theta.
to think like this: 270 degrees minus theta, which is 0.2 degrees. Is that clear to you? Do you see how we found it?
Yes, sir.
Simple as that. And magnitude formula, you know, square root of x1 minus x2 square plus y1 minus
Plus
y2.
y. Yeah.
So you have 4 minus 3, which is becomes plus 3 here.
Yeah.
All right. And plus y is minus 2 minus 5 whole square. You can calculate this to find the distance, correct?
Yes, sir.
Yeah. Calculate, what do you get?
Sir, I get approximately 7.62.
Fine. So what is the speed?
Sir, the speed would be that, right?
Time. Distance over time. Time is given to you. 2 hours,
Yes, sir.
3/4, right?
Right.
So convert to hours. 2.
So, sir, how would we? So, we're given the distance right now, right?
Distance divided by time. Speed.
Oh, okay. Yeah, yeah, yeah.
So
So,
3/4 of an hour, correct?
right.
Important, right? Which is how much? 2 point?
So, it would be 2.75?
Yeah. So 30 is 2.75. 3/4,
Yeah.
right? So divide this distance by 2.75, get your answer.
Okay. Yeah.
You know kilometers, and then this is in time is given in hours, kilometers per hour. Is it okay now?
Yes, sir. So, you would get approximately 2.77.
Do you understand how do we solve these questions now?
Yes, sir. I get it. I was just a bit confused with the bearing, but now I understand.
Yeah. So it's kind of tricky to begin with, but
Yeah.
otherwise not so difficult. So to now you can connect your physics with all this also, but we
Right.
have some more, power in vectors. That is, we have flexibility of using the coordinates. We can use the trigonometric
Yeah.
part of it. It's very flexible. And the concept is that the vector is not positioned anywhere. So when you're talking about this line, we could have thought about line at this position also. It makes
Yeah.
visualization easy, and therefore we could easily write down the angles, because to begin with, angles
Yeah.
is something very critical to find. Sometimes
Right.
we don't get them right.
Right.
So that is how I think we should be solving such questions. I hope the concept is absolutely clear to you, right?
Yeah.
Perfect. So that is it. And I think I don't have a solution of this, but that is all
Yeah.
we're trying to do. You get the idea, right?
Yes, sir.
And you can actually sit down and work out the solution and then see
Right.
exactly what we got, how close were you in calculating roughly in today's time.
Yeah.
Perfect. We'll kind of end our session here, since these are two very critical examples, but you can look into my YouTube channel on more applications. We call them relative velocity. Okay. Now
Yeah.
tell me first, what did you learn today? Then we'll share with you the YouTube channel.
Yes, sir. So we went over how to break down vectors into their x and y components, and also how to manipulate vectors using like the variables I and j, right? So with that in mind, I think it'll be much easier if I use like the I and j method, because cosine law and sine law takes a little long sometimes, right? And
Yes,
there's more chance for error.
correct.
So based on that, I think I'll work with the I and j method. So yeah.
That's great. So let me just share with you. I'll see what do I have on my YouTube channel, and then I'll
Yeah.
share YouTube channel, right? So just give me a second. Work on velocity. We work on force, distance,
Yeah.
torque, any other applications. Velocity to begin with is one of the best, right? It gives
Right.
you all the concept,
Right.
because you have two components, direction and magnitude.
Yeah.
That is what
Right.
velocity is. And we can mix many things as we have done here, wind
Yeah.
and the normal velocity. So that gives you relative velocity concepts also as you move along, and also working with more than one vector at the same time. Okay. Now, can you please read this question?
Yes, sir. An airplane is heading on a bearing of 125 degrees at 400 kilometers per hour. A wind is blowing on a bearing of 225 degrees at 200 kilometers per hour. Determine the magnitude of the resultant ground velocity of the airplane.
Correct. The critical thing here is to make the vector diagram. The diagram which I have shown here is the vector diagram. Once we talk about velocity, we also call it velocity diagram sometimes.
Right.
But okay. So bearing, you understand, just as we did, 400 kilometers per hour at the bearing of 125 means from north, that is the angle, and the point P shows plane. From the
Yeah.
origin, length O to P is 400 kilometers per hour
Per
representation,
hour.
and
Yeah.
the angle is shown to you as 125 degrees from north.
Right.
Similarly, the wind velocity blowing 225, 200 kilometers. So 225 is shown to you, is going in the third quadrant, as you can see, right? So it is
Right.
more than 180 degrees, less than 270 degrees. And there you go. So once you take that wind velocity over there, you can form a triangle, and the resultant R is
Right.
the end of this particular diagram. So you could use trigonometry, or you could use coordinate geometry. I mean,
Yeah.
split it into components X and Y and solve
Right.
this particular question. Both methods are equally good. So in this particular case, I think we have used the trigonometry cosine law.
Yeah.
Because when you begin with, unfortunately, when you begin with, you talk
Yeah.
about the geometrical operations, you haven't learned the algebra part.
Right.
So in the 6.1 units, 6.2 units, this is the
Yeah.
method which is being followed, correct? But when
Correct.
you move forward, you learn algebra part of it. So it's the same
Yeah.
question you could do in much simpler way. So that is
Much
why
simpler way. Right.
this playlist may just use trigonometry, cosine law,
Yeah.
etc. Because that is what you're familiar with, and you're beginning to learn vectors, right? So you haven't really
Right.
learned much of vectors. And so we have many related examples based on what we learned today. So I like you to
Yeah.
explore these questions, which are also test questions actually, and they
Yeah.
give you mastery over the topic. And you can also, instead of velocity, if I do force, for example,
Right.
and search the videos force and tension, we get more playlists, and in those you
Yeah.
can do force vectors, right? Tension we will take
Okay.
slightly later, since you know
Yeah.
when we talk about tension, we use products also, which you
Right.
haven't learned so far. So after two chapters we'll learn that part also. Is that clear to you?
Yeah. Yes, sir. I
So
think in physics, sir, we touched upon um tension too, right? But
correct,
when we touched upon tension, we broke it into the X and Y also, just like we did today.
just it, correct.
Yeah.
So when we talk about torque, then you have to have
Yeah.
a cross product between, because the vector
Two
thing,
vectors.
we'll
Yeah.
learn that much later. But at present,
Okay.
look into the force and tension part, because in
Yeah.
that we are only resolving into different components and
Right.
finding the solution, right? So many examples which you've done in physics. For example, here we have a inclined plane kind of a thing, which
Right. Right.
worked upon. Um, so those are the type of examples which you could see in the playlist, correct? So
Yeah.
leave the class here. You can actually explore and learn more. You get the idea.
Yes, sir.
So that's the end of the lesson. So is everything clear to you, Akshay?
Yes, sir. Everything's clear.
Perfect. It needs a lot of practice. I mean, yes,
Right.
I
Right.
shared with you two basic examples, but once
Yeah.
you start working with examples, you'll come to know so many different things. So it needs a lot of practice, and
Yeah.
especially making exact diagrams is very important here in vectors.
Yeah.
For every question, try to sketch a diagram and then
Yeah.
solve it. Right? Even if you
Right.
know you have to resolve it to X and Y components, try to sketch the diagram, resolve it. From the
Yeah.
diagram itself, you get an idea of what could
You're
be.
right.
That's the advantage. Is that clear to you?
Yes, sir.
Perfect. So go ahead with this, and I think that'll be great. We'll see you
Yeah.
next time and learn more.
Okay, sir. Yeah.
Thank you then. All the
Thank
best.
you so much, sir. Have a great day.
You too. Bye.